Hi everybody, welcome back to the section 2.3 video. Let's go ahead and look at another example of a linear differential equation and solving it using the same step-by-step method. So here we have a differential equation, x times dy over dx minus 4y equals 6 to the x, e to the x. Okay, so a lot more complicated than our last problem. We have some actual functions here and not just constants. But the same steps are always the same. You want to start off by getting our derivative dy over dx naked. So we're going to divide by x. Okay, we're going to clear that out. So divide by x to both sides. And so what we're left with is dy over dx minus 4. I'm going to write it like this, 4 over xy. That way we're just keeping our functions of x clean, and then this would be x to the fifth, e to the x. So I'll write it again here, standard form. Remember, standard form is dy over dx plus some function of x p times y equals q of x. So that means negative 4 over x is my p of x. And x to the fifth, e to the sixth is my function q. Okay, so we're in standard form now. We can go ahead and start getting our integrating factor, which is step 1. Okay, so integrating factor, mu. Okay, so remember, mu is calculated by e raised to the integral of p dx. So this means that our e will be raised to the integral of negative 4 over x dx. So the integral of negative 4 over x is going to be negative 4 natural log of x. Okay, so when that happens in this integrating factor, there's something that you want to recognize and do with properties of natural log. What I want to do is bring up this negative 4. And the reason we do that is we'll be left with e to the natural log absolute value of x to negative 4, and the e and natural log cancel out. And so what I'm left with is absolute value of x to the negative 4, but since it's to the fourth power, I'm just left with, we could drop the absolute value. And so what I'm left with is going to bring down the exponent, but 1 over x to the fourth. So this is my integrating factor mu. So once we get our integrating factor, we're going to take it and multiply it to both sides of the differential equation. So step 2, multiply mu to both sides of the differential equation. So here I have 1 over x to the fourth times dy over dx minus 4 over xy. Then I'll close that off, equals the right-hand side, x to the fifth, e to the x, being multiplied by our integrating factor, 1 over x to the fourth. So when I distribute this in, a couple things happen. Uh, on the left-hand side, we get dy over dx. Well, let me write the 1 over x to the fourth in front. Minus 4 over x to the fourth times x is x to the fifth times y. I'm trying to keep the y's and x's separate. And then on the right-hand side, we can see that x to the fourth and x to the fifth would cancel out and just leave me with x e to the x. Okay, so same thing as the last problem. I want to rearrange this a bit. It doesn't take much rearranging, but I want to rearrange this a bit to show that this is the pro derivative of some product. So let's rearrange it like this. 1 over x to the fourth times dy over dx plus negative 4 over x to the fifth times y equals x e to the x. Okay, so this right here is a derivative of some product. So 1 over x to the fourth would be f. Negative 4 over x to the fifth is its derivative. And if you don't believe me, we could convince you off to the side. So the derivative of 1 over x to the fourth, remember, we would need to bring it up to use a power rule. So if we take a derivative of x to the negative fourth, it'd be negative 4x to the negative fifth, which is the same thing as negative 4 over x to the fifth. So if you don't believe me, there's some side work that could convince you. But y is our g and dy over dx is our g prime. So this is the product using the product rule of 1 over x to the fourth times y. And our right-hand side stays the same. So remember, if you don't get a derivative of a product, something went wrong. Okay, so that's a good indicator. So if you're not able to piece together that this is some product rule, something went wrong in your method. Okay, so this is what we have now, and then we move on to step 3, which is integration of both sides. Okay, so here I have d over dx, just rewriting it, x to the fourth times y, x e to the x. And I need to integrate both sides. So if I integrate both sides, the integral and derivative cancel out. And so I'm left with 1 over x to the fourth times y equals the integral of x e to the x. And here we're going to need integration by parts. So integration by parts, let's go off to the side and work that out. So here's my by parts. Let me write that a little more. Integration by parts. And so what would my u be here? U would be my polynomial, so it'll just be x. And my dv would be e to the x dx. Oh, forgetting a little dx there. Okay, but u and dv, that means du would just be dx and v would just be e to the x. So this one's definitely a simpler integration by parts that we can have. And remember the method, it's uv minus the integral of v du. So coming back to the problem now, what we would have is 1 over x to the fourth times y equals, looks like it would be x e to the x minus the integral of e to the x dx. I like to cross. Okay, and almost done. 1 over x to the fourth times y equals x e to the x minus e to the x plus c. And I can divide it, multiply everything by x to the fourth. So I'll have x to the fourth times x e to the x minus e to the x plus c. And we'll leave it like that. Okay, so that's how we would do this linear equation. That's how we would solve it. Same three steps. We need to isolate dy over dx. We need to get our integrating factor, multiply our integrating factor to both sides, recognize that this is some product, derivative of some product, and rewrite it into some derivative of a product like this. That's always the indicator. And then step three, integrate both sides and solve for y. Okay, so that's another example. Once again, these problems are a bit long and take a little bit of time and detail. But that's it for this video. I'll see you in the next one. Okay, take care.